Okay, so I want you to look at your lab now. I want you to pull out this sheet, the second sheet of your lab. It looks like this at the top. It says forces in circular motion at the top. And I'm sorry, that's very blurry. Forces in circular motion. And I'm going to work through just a few of these with you. Okay. So to start off, I want to look at number one. Look at number one, and let's read that problem. Number one says a 0.1 kilogram ball attached to a string is being swung around in horizontal circles with a radius of 1.25 meters at a speed of 5 meters per second. First thing I want to do is just define everything that we're given. Our mass is 0.1 kilograms. It tells us that these are horizontal circles, not vertical. That's very important. You might want to write that down. And that means different things. We'll talk about that in just a second. Radius it gives us is 1.25 meters. And the speed, v, is 5 meters per second. Right, and part A just wants us to draw and label the forces that are acting on the ball. Okay, remember this is a horizontal circle, so it's going to look something like this. Okay, horizontal circle, and we talked about this just a little bit ago. There's actually two forces that are acting. One is gravity, which always goes down, and the other one is tension in the string. And the tension in the string can either go left or right depending on where you're catching the ball in the path, whether you're catching it here or here. Here, tension goes right. This side, tension goes left. Okay, so that's all you have to do for part A, is you're just drawing and labeling the forces. So in a horizontal path, this is what your forces look like. Alright, now let's move on, and part B says to calculate the magnitudes of each of the forces. So we have force of gravity and the tension force. We need to calculate the magnitudes of both of those. Well, how can we calculate the magnitude of the force of gravity? Well, don't forget that the force of gravity is the same thing as the weight. And you might remember that we calculate the weight using this equation, W equals mg. Weight equals mass times gravity, and we simply plug our things in. Mass is 0.1, gravity is 9.8, and the weight, or the force of gravity, same thing, is 0.98 newtons. 0.98 newtons. Okay, so that's one thing. That's one of our forces. The other one is the tension force. How are we going to calculate the tension force? Okay, well, we're talking about circles. We're talking about circular motion. And I want you to look at your notes right now. There's only one formula that we used that even has force in it. Look for that formula real quick. Okay, hopefully you found your centripetal force formula, which is this: mv squared over r. Centripetal force. So that's centripetal force. And the centripetal force, remember the definition of it, is the force that keeps an object in a circular path. And let's remember, with a horizontal motion, with horizontal circles, there's only one force that will contribute to the centripetal force. The force of gravity does not contribute to the centripetal force. So no Fc right there. What does contribute to the centripetal force is this tension force. So what we can say is the tension force equals the centripetal force. It is the centripetal force in this case. So now all we have to do is plug things in here. Alright, so the tension force, which equals the centripetal force, mass is 0.1, velocity it gave us was 5, and make sure that's squared, and the r is 1.25. Punch that into your calculator real quick and tell me what you get. Hopefully you should get 2 newtons. So that's our tension force. Alright, so that's number 1. Here's what I want you to do. Go down and cross out the very next problem. We're not going to do, so don't do 2 A through D. Don't do that one. And then turn to the very back and do not do number 5 and number 6. Cross both of those out. But I do want you to do the rest of these. Problems like this will be on your quiz. So let's look at number 3. This is number 3. Look at number 3. A 0.25 kilogram mass is attached to a 1.5 meter long string. The mass is moving in a horizontal circle with a speed of 7.85 meters per second. And it wants to know what's the tension in the string. Tension in the string. Alright, so once again, we're moving in a horizontal circle. Okay, horizontal. We've traced these forces before. We just did it up here with this problem. It's the same thing. We have gravity, which is not going to play a role in the tension force, and we have, or the centripetal force, and we have tension force. Got it working. Tension force is the centripetal force in this case. Alright, so the only force equation we have for circular motion is mv squared over r. And in this case, the tension force is the centripetal force. We are trying to find the tension in the string. So once again, we simply plug things into our equation. Mass is 0.25. 7.85 is the velocity, and that's squared. And 1.5 is the radius. Punch that into your calculator and see what you get. Hopefully you should come out with 10.3 newtons, which is good. I don't know if you've noticed by now, but all of the answers for these questions are in parentheses. 10.3 newtons. Alright, last problem. Let's do number 4. Number 4. It takes a 615 kilogram race car 14.3 seconds to travel at a uniform speed around a circular racetrack with a 50 meter radius, and we want to know the car's speed. Alright, there's a couple of equations that we had that have speed in them. Okay, we can have, first of all, the speed equations that we looked at. We looked at this one, and we also looked at this one. 2 pi r over period, 2 pi r x over time. We also had this one that mentions speed. Those are the only choices we have to calculate speed in a circle. Okay, and this one is out because this problem doesn't give us any forces. Okay, it doesn't give us any forces. We have to calculate it in just a little bit, but for the first one, to find the speed, we can't use this one because we don't have any forces. So we're stuck with these two. And the only thing between these two, the only difference is whether we're using period or whether we're using total time for more than one revolution. So the question is, how many revolutions do we have in this question? Well, we only have one revolution. If we had more than one, it would have told us it was moving around the track more than once. But there's only one revolution. And because of that, we're going to use this equation with period because it gives us the period. That 14.3 seconds is the period. That's how long it takes to travel one time around the track. Okay, so this is the equation we're going to use, and we simply plug everything in. 2 pi, the radius is 50 meters is what it gives us. And we divide by the period, which is 14.3. This, I don't know why I drew that all the way across. 2 pi times 50 divided by 4.3. If you calculate that out, you should get 22.0 seconds if you round it. Okay, that's part A. 22 seconds. Next, let's look at part B. It asks us what force must the track exert against the tires to produce this acceleration. All right. Again, the only equation we have for force, this is part B, is mv squared over r. Okay. We just found the velocity, and we can plug that in here for v, and everything else we have, and all we have to do is solve for the centripetal force. Now, how do we know that the track is exerting this force against the tires? Well, once again, if it's a car, so we'll draw our car, and it's going in a circular path, there's got to be a force pulling it toward the center of the circle. And with a car, that force is the frictional force. So that's what we're going to calculate. Frictional force is the centripetal force. Alright, so we'll plug everything in. Mass is 615. Velocity we just found to be 22, or speed. And the radius is 50. And if you calculate all that up, the centripetal force is 5953.2 newtons. And that is part B. All right. Good luck with the rest of the homework. Let me know if you have questions.